Hey, what's up, guys? Thanks for visiting. Today we're going to be learning about systems of equations, and we're about to go modern warfare on the graphing method. We're going to have a good time. We're going to laugh. We're going to learn. We're going to practice. But you better be ready because it's about to go down. What up, what up? Thanks for visiting. I am your teacher and facilitator, D Math Professor. And guys, you already know what time it is. If you see the button, go ahead and hit me with the subscribe. Or if you like what you see and what you hear, go ahead and hit me with a like too. Today we're going to be learning about systems of equation with a special focus on the graphing method. Try to make that thing a bit mysterious. Graphing method. Now, the graphing method is one of my favorite because it incorporates all the different skills that you should have learned at this point in being able to graph what we call a linear equation or an equation in slope-intercept form. And the idea behind systems of equations is to be able to identify three different types of solutions. There are three different types of solutions, which was mentioned in the previous video. So if you didn't get a chance to check that out, please do so. But I'll quickly review. The first type was no solution. That means there is nothing or no solution or no answer that is going to tie both of these equations together. In other words, there is no answer that makes either equation true. Okay, and so that's what no solution is. Okay, and we're going to be able to, today we're going to focus on what that even looks like on the graph. The second type of category is a one solution. A one solution is when you have specifically one answer that makes two equations true at the same time. And that's how it works, okay? So you have two separate equations, hence the word systems, and there is one answer between both equations that make them true. And the last category is going to be called infinite or many solutions. And infinite or many solutions is basically when you have so many solutions or so many answers between both equations that make both equations true. Now that one is one of my favorite because it's almost one of those things where everything works, okay? And so that kind of brings me to like a story of how I'm able to lock in systems of equations. So I kind of treat systems of equations like a first date, okay? Whenever you go out on a date, and depending on how old you are when you're watching this video, you may or may not relate. When you're dating someone, you're trying to find out what you all have in common. Do you have something in common? Do you have nothing in common? Or do you have so many things in common? And you know, when you find that person that you have so many things in common with, that's probably going to be the right move. All right, so quickly, let's just kind of check this out. Roll that beautiful bean footage. Always wanted to say that out loud. Hey, listen, I just want to thank you for being able to come out here with your boy. I know you got a lot on your plate, but it's good to be able to get out, you know, and definitely been feeling you for a little bit. And so definitely looking forward to the fact that we're out here today. Oh, a little bit about me. Oh yeah, cool. Yeah, you know, I'm a math teacher. I teach algebra. I've been doing it for several years now. I definitely love working with kids. I especially love the looks on their faces where you're able to take something they view a bit complicated and you're able to break it down and they truly understand it. Okay, yeah. Tell me a little bit about yourself. I mean, what do you do?
Well, I'm pretty simple. I love watching movies and hanging around the house with my cats, all 7 of them.
Cats?
Yes, cats.
Check, please. Okay, so we're getting ready to jump into a couple of examples where you all get a chance to see what it looks like when you solve a system using the graphing method. I have these two equations which are currently in standard form. I got negative x plus 2y equals 2, and then I have 3x minus 6y equals 12. Remember, I want both of these equations in slope-intercept form in order for me to graph them, so I'm going to have to move some things around. So let's go ahead and write this equation, which is negative x plus 2y equals a positive 2. Now, I know that I want the y to be isolated or by itself, so I'm going to have to move this negative x to the other side. So that's what I'm going to do. We got to move it. And I know I could only do that using addition or subtraction. Cool. So since it's already being subtracted because it's negative, I'm going to use the opposite. In this case is a positive x. So I'm going to add x to both sides of my equal sign. Okay, remember that rule. If I have the same value, but one is positive and the other is negative, they will always cancel out or equal 0. So in this case, I am left with a 2y equals x. In fact, let me write it this way. I'm left with a 2y equals x plus 2. All right, but I'm running into a problem because when I looked at my slope-intercept form, it just said y equals mx plus b. It didn't say 2y equals mx plus b or 3y equals mx plus b. So clearly there's not supposed to be a number attached to this y. In this example, I got a 2 attached to the y. So guess what, guys? I have to get rid of this 2. And whenever you got to get rid of 2 or a value, you can only do so using multiplication or division. Remember these rules because they help you manipulate or navigate through an equation. If I'm moving something, I'm doing that using addition or subtraction. If I'm getting rid of something, I'm doing that using multiplication or division. So in this case, I'm looking at 2y. I know that whenever I have a 2y, oh, let me use this guy right here. If I have a 2y, or if I have a number and a variable and no operation between them, like it doesn't say 2 plus y, 2 minus y, 2 divided by y. If there is no operation between them, then that operation that I'm viewing is currently multiplication. And so in order for me to get rid of it, I have to do the opposite of multiplication. In this case, it's division. So I got to divide everything by 2. Divide by 2, and then divide by 2. All right, great. So now I notice that 2 divided by 2 is 1, so that's going to cancel out. Now let's write down what I am left with. I got y equals x divided by 2 plus, and I know that 2 divided by 2 is a 1, so plus 1. Okay, but I like to rewrite that x divided by 2 because it looks weird. And the way I like to do that is I'm going to rewrite this as y equals. I shift my x to the right and then make that number in place of x a 1. So it's really 1 divided by 2 or 1/2 x plus 1. So that's my new equation. That is definitely my new equation. So what I am now going to do is grab. Okay, so let's go ahead and graph it. All right, so same concept. I have my y-intercept, which is 1, and I have my slope, which is 1 over 2. So I'm going to go ahead and start at my y-intercept. I'm going to go to the y-axis and find a positive 1 and put a point there. Great. Okay, so now I know my slope was a positive 1 over 2. So that means I'm going to, from that point, I'm going to go up 1, over to the right twice. 1, 2. Put a point there. And then I'm going to do the same thing from here. I'm going to go up 1, over, up. I'm going to go up 1, over to the right twice. 1, 2. And so I got that. But I also want to create the second half of my line. So if I was going up 1, over to the right twice, I got to do the complete opposite to create the second half, which is to go down 1 to the left twice. 1, 2. Down 1, over to the left twice. And so at that point, I have everything I need to create my line. So that's what I'm going to do. I'm going to connect all of these points. There we go. So we got our first line. So now let's create the second guy. I'm going to go ahead and delete this. Need that space. And we're going to write the second equation, which says 3x minus 6y equals 12. All right, and keeping in line with the same spirit of things, we know that the first thing we got to do is move this 3x. We got to move it, and we could only do so using addition or subtraction. Well, it's already positive, which means I have to do the opposite, which is subtraction. So I'm subtracting 3x from both sides. For those of us that are still confused with the concept of positive and addition, subtraction and negative, if the signs look the same, they typically represent the same operation. So because it was a positive 3x, it represents a plus 3x. All right, remember the rule. I got a positive 3x and a negative 3x. We know that they are going to cancel out. I am now going to be left with a 6y equals a negative 3x plus 12. All right, great. So we got an issue. There is a 6 attached to the y. And remember, when we're graphing in slope-intercept form, we don't want anything attached to y. We just want the y to be by itself as seen here. So what we're going to do is get rid of 6. We're not going to move it. We got to get rid of it. So because we're going to get rid of it, I have to use either multiplication or division. I'm looking at 6y. If there's no operation between them, then clearly they're currently being multiplied. So in order for me to get rid of it, I have to do the opposite, which in this case is division. Okay, and I'm going to remember that the 6 was negative, so I'm going to put a negative 6 down here, a negative 6 down here, and a negative 6 right here. So let's go ahead and do that math. That is now going to leave me with negative 6 divided by 6 is going to cancel out. So I got a y equals, excuse me, move that away, a negative 3 divided by a negative 6x. And then I have plus 12 divided by a negative 6. Now I know I can simplify 3 over 6 and I can simplify 12 over 6. So that's what I'm going to do. So I'm going to rewrite this as y equals negative 3 divided by negative 6. I have two negative signs, so you know that now becomes positive. So that's a positive 1 over 2x. And then I know that 12 divided by a negative 6 is going to give me a negative 2. So let me put a negative 2 here. All right, I think I got everything I need. Let's put a little spacing there so we're good. All right, so now I'm going to go ahead and graph. So the first thing I'm going to do is I'm going to find my current y-intercept. In this case, it's a negative 2. I'm going to go to negative 2 on the y-axis and put a point right there. And then, according to my slope, I'm going to go up 1 over to the right twice. So up 1 over to the right twice. 1, 2. I'll do that again. Up 1. Up 1. Up 1 over to the right twice, which puts me right there. Okay, and I want to create this second half of my line, so I'm going to go down 1 over to the left twice. 1, 2. All right, I think I got everything to create my line, so that's what I'm going to do. And I'm going to connect all of these points as best as I can. Definitely want to extend the line. Right there. So in this particular example, we are looking at a no solution. And it is a no solution because they don't intersect. Okay, that means they have nothing in common. Because this is a no solution, they don't intersect. And I'm just gonna go ahead and interject one particular thing here. Whenever you're graphing, if your slope is exactly the same, please remember that it will always create a parallel line. So let me write that so that way you all can remember it. So if I have the same slope, it's going to create a parallel line. Same slope, parallel lines, which automatically tells me it's going to be no solution. All right, cool. Hey, listen, I really appreciate you taking the time out to come out here with me. I know that you got a lot on your plate. You know, you're dealing with a lot, but you know, sometimes it's just good to kind of get out and get things off your mind for a little bit. And, you know, I definitely been feeling you for a bit. So again, you know, oh, You want to know a little bit about me? Cool. Well, you know, I'm an algebra teacher, an educator, and I've been one for several years now. Love teaching algebra, love working with kids. I just love to be able to see their faces when they're learning. It's an amazing process. Tell me a little bit about you.
Well, I enjoy hanging around the house. I just closed on a brand new house. And watching movies.
I get it. Yeah, I understand. So, what do you do for a living?
So my job? Well, that's a little complicated.
Complicated?
A little complicated.
Man, you ain't got no job. Check, please. First things first, I am looking at my equation, and I notice that I have x plus y equals -4, and -2x plus y equals 2. Now, whenever I'm graphing, I always want to make sure that my equation is in slope-intercept form. That's where you have your y equals mx plus b. If you are not familiar with what slope-intercept form is, I suggest that you go back a couple videos and check that out. I'll add that video in the description to the link. All right, cool. So I'm going to take my very first equation, and that says x plus y equals -4. So x plus y equals a -4. And I noticed that with the slope-intercept form, my y is the only thing on the left side of the equal sign. It's by itself. There's nothing over there with that y. So I want to keep that mindset whenever I'm looking at an equation. I always want to have y isolated. I want y to be by itself. So when I'm looking at x plus y, I notice that this x is on the same side of the y. So that means I have to take this x right here and I have to move it. So here's a rule of thumb. Whenever you have to move an object or a variable, whatever, whenever you have to move something within an equation, you have to use addition or subtraction. Okay, so the only way that I can move something within an equation is to use addition or subtraction. Keep that in mind. So whenever you're looking at equation, you're asking yourself one of two questions. Am I moving this, or am I getting rid of this? If you're moving this, then you have to use addition or subtraction. If you're getting rid of it, which we'll get a chance to see in a couple of other examples, then you have to use either multiplication or division. So remember that. All right, so since I'm moving this x and it's positive, I can't use addition to get rid of it because that'll make it bigger. I have to use subtraction, which would get rid of it. So I'm going to use the opposite operations using properties of equality. So I'm going to do the opposite of what I see. So I'm going to subtract x over here, subtract x over here, and then I'm going to find that these two x's right here cancel out. So that's going to leave me with y by itself, an equal sign, and then I have a minus x and a -4. So that's my first equation. All right, y equals -x minus 4. Now I have it in slope-intercept form. My y is isolated. I got a -1x or a -x, and then I have a -4. So I have my y-intercept, which is -4, and I have my slope, which is the number in front of the x, which in this case is a -1. I got everything I need to graph this, so I'm going to go ahead and graph this specific equation. So the first thing we do, again, which was covered in previous videos, is I want to put my starting point or my y-intercept. I always want to plot that first. In this case, my y-intercept is a -4, so I'm going to go to the y-axis and find -4 and put a point right there. Boom, there's my point. And then I want to follow my slope. My slope is a -1, which means I'm going to go down 1 over to the right 1. I'm going to do that again. I'm going to go down 1 over to the right 1. Now, what you're going to realize is I'm running out of space. I can't create a line if I run out of space or get off the graph. So another strategy is to create the other side of this line, which would be somewhere here, by just doing the opposite of your slope. So if I was going down 1 to the right 1, the opposite of that is going to be to go up 1 to the left 1. And I'm going to do that a couple times until I've established a line. Up 1 to the left 1. And now I think I've developed a line. So let me go ahead and connect these points the best way that I can. Great, but I'm going to extend this line a little bit because I want it to go as far out as possible. So without changing anything, so there it is right there. Great. I have the line for the first equation. All right, so now I'm going to rewrite the second equation and do the same thing. I got a negative 2x plus y equals a positive 2. Again, based off of the formula, I know that I gotta move this negative 2x because y needs to be here by itself. And I need to move that guy. And according to what we talked about, the only way that you can move within an equation is to add or subtract. Well, currently it's being subtracted because it's negative. So I can't subtract it because that would make it more negative, if that makes sense. So the only option I have is to do the opposite of subtraction. In this case, it's addition. So I'm going to add 2x on both sides of my equal sign. I'm adding 2x. So far, so good. Now I'm going to rewrite this equation, and I notice that this negative 2x and the positive 2x, they cancel out. Rule of thumb, if I have the same value, but one is positive and the other is negative, it will always cancel out. It's an identity rule, so it will always cancel out. So what am I left with? I am left with a y over here by itself equals a positive 2x plus 2. I think I have everything I need to graph now because there's my y-intercept and there's my slope. So let's go ahead and plot the y-intercept first, which is at a positive 2. Put a point at positive 2 on the y-axis. Okay, now I follow my slope. The slope is a positive 2, which means I'm going to go up to 1, 2, and then over to the right 1, and put a point there. And then I'm going to do the same thing again. I'm going to go up to 1, 2, and over to the right 1. Okay, but I noticed that the further up I go, the further away I'm going from this line. So I want to try to see if this is going to touch. So I got to go in the opposite direction. So remember, when you're creating a line or the second half of a line, you have to do the complete opposite of what your slope says to do. So if I was going up to 1, 2, over to the right 1, now I'm going to be going down to 1, 2, over to the left 1. Down to 1, 2, over to the left 1. So now I have a complete line. Let's go ahead and connect this. All right. And it seemed like we're right there. Oh, let me move that guy over a little bit. There we go. So great. Now I notice that I have two lines that intersect right here. So the only thing left for me to do is to tell you where they intersect. And according to what I'm seeing, I see -2 and -2, -2 and -2. So they intersect at -2 and -2. I am clearly looking at a one solution scenario or type. And I'm looking at a one solution type because they only touch one time, or they only have one thing in common. All right, great. Hopefully that helps. Some things to walk away from is if you're moving something within an equation, you got to do so using addition or subtraction. Okay. So I really appreciate you taking the time out to, come out here with me. I know that you got a lot on your plate and you're dealing with a lot, but sometimes it's good to just be able to, get out and hang out for a bit, and I definitely have been feeling you for a minute. So, I'm excited that we finally get a chance to be here. Oh, you want to know a little bit about me? Cool. Well, I'm an educator. I teach algebra and I work with kids. I really feel like it's my life's work and my life's passion to work with kids, especially in algebra. Where you get a chance to work with kids and see their faces when they learn. That learning process is an amazing thing. But enough about me. Tell me a little bit something about you.
Well, I love hanging around the house and watching movies. I don't live with my parents. I own my own house. Yes.
Okay, and so what do you do for a living?
I am a CEO at a company.
Oh, okay, you got a job.
Yeah,
All
yeah.
right,
I
hear
really
you.
enjoy doing what I love.
Okay. All right, cool.
Yeah, it's
All
pretty
right,
good.
we seem like we got a lot going on in common. I like this. All right, cool. Nah, we don't need to check. We good. We gonna stay right where we at. We gonna stay right where we at. All right, let's dive into our last example. Okay, at this point, I think you all should feel comfortable about what we're looking at. We're looking at two standard form equations. I want to graph it, so I'm going to have to do some conversions. So I'm going to rewrite this as negative 8x plus 2y equals a positive 8. And the first thing I want to do, of course, is move this negative 8x. I got to move it. Okay, we can only do that using addition and subtraction. It's already being subtracted, so I got to add. I'm gonna add an 8x on both sides. I'm gonna add an 8x on both sides. And remember what we talked about. I got a positive 8 and a negative 8. They will cancel out. That is going to now leave me with a 2y equals 8x plus 8. Oh, wrong number. 8x plus 8. Let's drag that down so we can see those numbers. All right, great. All right, so now I got my 2y equals 8x plus 8. We know we should not have a coefficient in front of y. We shouldn't have a number in front of y. So we got to get rid of that guy. Okay, and at this point, when we get rid of, we got to use a multiplication or division. So in this particular case, I'm going to divide because 2y is being multiplied. All right, so divide by 2, divide by 2, and divide by 2. Okay, we know this is going to cancel out. Let's go ahead and write our new equation. It's now going to be y equals 8 divided by 2 is 4x plus 8 divided by 2 is 4. 8 divided by 2 is 4x. 8 divided by 2 is just 4. So we got our equation. Let's go ahead and graph it. I'm going to go to my y-intercept, or my y-axis, and look for the number 4. That's this guy. And I am going to follow my slope. My slope says to go up 4. 1, 2, oh, we ran out of space. I can't go any further up off this graph, which is why that skill of being able to create the second half or the other half of the line is so important. So since I can't go up 4 to the right one, then I can go down 4 to the left one. So 1, 2, 3, 4 to the left. Oh, sorry. So I'm going to go down 1, 2, 3, 4 to the left one, puts a point right there. And then I'm going to do it again. I'm going to go down 1, 2, 3, 4 to the left one, which puts a point right there. I now have everything I need to connect these 3 points, and I'm going to do so like such. And I definitely want to, well, I'm not going to extend the line. I think we're good. We got a good idea of what this line looks like now. All right, great. So now I'm going to do the same thing. I'm going to rewrite the next equation, which is 4x minus y equals, is that a negative 4? Let's see. Yes, that's a negative 4. Equals a negative 4. All right, so now, same rule. I got to move this 4x because it does not belong there. So I'm going to move it using addition or subtraction. It's currently being added, so I'm going to subtract, do the opposite. Minus 4x on both sides. Okay, that is now going to leave me with the equation negative y equals a negative 4x minus 4. Negative y equals a negative 4x minus 4. Now, again, when we look at the slope-intercept form, there is nothing in front of y. There should not even be a negative sign in front of y. But because there is, I got to get rid of a negative sign. Now, there's no operation that teaches how to get rid of a negative sign. So what you have to remember is that there is a 1 directly in front of that y. So whenever you see a variable, x, a, b, c, d, e, f, g, and you don't see a number directly in front of that variable, the number in front of it is 1, okay? And we tend to show the 1 when we're ready to use it for some kind of operation. So there is a -1 in front of that y. So I know that I have to get rid of this -1 using division because that's -1y. So I'm going to divide by -1. I'm going to divide by a -1, and I'm going to divide, oh, sorry, put that back. And I'm going to divide by -1. And that's going to now recreate the new equation. Y equals 4x plus 4. So when it comes time for me to have to graph this, I'm going to go to my y-intercept and I'm going to put a point at +4. Oh, there's already a point at 4. My slope says to go up 4 and over to the right 1, but I can't because I ran out of space, so I can only go backwards, which means I'm going to go down 4 to the left 1. Oh, already did that. Down 4 to the left 1. So in essence, this created the same exact line. I have, let's go ahead and I'm going to graph it anyways, so that way you all can see it. Graph it anyways. Down 4 to the right 1, graph it anyways, and then I'm going to connect those points, which is going to now create this line. And what you should notice is that I have 2 lines that are exactly the same. And when that happens, we're looking at an infinite solution because there are too many solutions. In other words, they have a lot in common. Okay, hopefully this helps. You guys enjoy it. See you the next time. Deuces.